P0740. Everybody knows about this code, the great torque converter code. The torque converter clutch solenoid valve is activated, so the TCM is turning on the TCM or the TCC solenoid. And basically, lockup operation is prohibited when the TCM fluid's too low. So basically, what is going on here is this here is a circuit code. So it is looking at when it's on or when it's off, and it's looking at the voltage is not correct. So the 740 code is a circuit code. Solenoid resistance to be 3 to 9 ohms. And if you're looking on the scan tool, can be a little bit confusing, but PID ISO-LT1 is the lockup solenoid. So when it's off, you should have 0 amps. When it's on, you should be looking at about 0.7 amps. That's the normal value. So the lockup solenoid is right here. And if you want to measure your amperage, or the voltage in amperage, is pin number 12 here at the case connector. So here's design one. Let's go into a little bit more on testing. Basically, you have the solenoid is grounded to the valve body, so you only have one wire to deal with. We have fluid coming in from the tip here. When it's off, it's exhausting through the top of the solenoid here. So the solenoid's open. Solenoid regs coming out. Solenoid regulator oil's coming through the center here, and when solenoid's on, oil's going down to the valve itself. So testing, we can back probe on design 1 at pin 3 or pin 12 as a transmission case connector. You should have 0 volts as the TCM is commanded on as voltage increase. So when it's off, you're going to have 0 volts. As lockup duty cycle ramps up, the voltage is going to be increased. The computer's looking for amperage, so you should have 0 amps when it's off, and when it ramps up to full lockup, you should have 0.7 amps. Design 2, everything's pretty much the same on design 2. The difference is you'll be testing at pin 38, the TCM connector. The amperage and all that is the same, 0 to 0.7 amps. Alright, so the P0744 ATTC switch function lockup is what design 1's calling it. Design 2 is torque converter clutch performance code, so they kind of changed the names on design 1 and 2. This code is for TCC slipping. You know, this can be a faulty solenoid, of course, mechanically, lockup valve sticking, bad converter, something along those lines. So what the set condition is, the computer is ramping up amperage and it's not seeing the lockup come on. So they don't give us a slip rate. They're not giving us any specs on what the set condition is. But basically, amperage goes up and it's not seeing the input and the primary pulley, the engine input or engine speed signal and the primary pulley speed signals are not matching, so that it's detecting the slip. So on the scan tool, what you can do is you can look at engine speed and look at your primary speed signal, and then also your TCC amperage. When TCC amperage goes up, those speed signals should match. So engine speed and primary speed should match. If they don't, it's going to set the 740 code. Possible areas of concern here are torque converter, of course, TCC solenoid, TCC select solenoid, lockup select valve, lockup regulator valve, a leak in the TCC circuit. And then, of course, engine and speed signals, if they're not correct or erratic, they can set this code also. P0745 line pressure solenoid valve. So here we are at line pressure solenoid. On the scanner, line pressure solenoid is ISOLT2. At an idle, you're going to be at roughly 0.8 amps. The more load you give it, the lower the amps. So less amps, higher pressure. This code's going to set if there's no amps, or if the amps are too high. So open or closed circuit, or open or shorted circuit. We'll set this code. The pressure control solenoid A regulates basically the oil pump pressure and discharge pressure to regulate mainline pressure. Here is basic wiring diagram for design 1. You're looking at one wire again. Solenoid is self-grounding. Solenoid regulating oil is going to the center of the two O-rings. Excuse me. But the solenoid regulator oil is going in between the two solenoids here. Oil goes out the end, or the tip of the solenoid, to the pressure regulator valve. We have 3.9 ohms resistance on these solenoids. There's a couple different designs. This here is the design 2 shown. Design 1 is right here. It has like a black tip. It kind of looks like your Nissan RE5. Here's our pin information on design 1. It's pin number 1 of the TCM and pin number 2 of the transmission case connector. So if you wanted to measure, it'd be measure between ground and either one of these pins, pin 1 or pin 2, and you should get 3.9 ohms. A better test is going to be hook up a amp clamp around the wire and see if the scanner readings match your meter readings. Here's design 2, same thing, same resistance and all this. We are going to change the pin information though. TCM pin number 40 is going to be for design 2. And pin number 2 at the transmission case connector still. You're going to have 3.9 ohms to the solenoid. Either way, we can load test a wire, hook up an amp clamp. Normal amperage is 0.8 amps at an idle and drops to engine load just like the other design. Alright, now we're moving on to P0746 pressure control solenoid A performance. Notice it said performance. Line pressure control solenoid A is line pressure solenoid. It regulates oil pump discharge pressure to suit the driving conditions in response to the signal sent to the TCM. So basically this code set conditions. Unexpected gear ratio was detected in the low side due to excessively low line pressure. To keep it simple, the computer is seeing a ratio issue and it's blaming the solenoid because it thinks that it has too low a pressure and that's why the transmission is slipping. So it's set in a 746 code. So possible causes: low pressure in the control system. This includes like flow control valve, very common. Pulley issues with the seal or leak in the pulley system. Valve body, stuck valves, PR valve. Other sticky valves can also cause this. And you can also get this from speed sensor operation, but that's not considered normal. Usually speed sensors aren't this issue. It's usually a flow control valve or a leak in the system itself. So how can we check this on the scan tool? On the scanner, you can basically go to your PID for PRI pressure. So PRI pressure at an idle should be 0.3 to 0.7 millipascals. This is a normal reading. Check primary and speed sensor operation on the scan tool. Then we can go to our line pressure. Note, you need a special gauge that can handle 1,000 psi, and also the hose will handle that pressure also. Line pressure ports here at the arrow. Go ahead and hook up a suitable gauge or transducer, and idle in reverse, drive, and low should be about 108 psi. You stall it up, it's going to raise the pressure to 768 to 826 psi roughly. So you have a lot of pressure here. You have to have a special gauge on this thing, or you are going to hurt somebody and make a huge mess. Main common issues found are the flow control valve, stuck or worn, sticky valves in the valve body, or leaks in the pulley system. Usually when I see this 746 code, next thing I'm doing is pulling the pan. If the pan's dirty or even discolored, I'm going inside the unit. P0776, pressure control solenoid B. This is a performance code. It's saying the secondary pressure solenoid valve regulates secondary pressure to suit the vehicle driving conditions in response from the TCM. So the TCM sending a signal to the secondary pressure solenoid valve. It's monitoring the secondary pressure at the secondary pressure switch or sensor, and basically it is too high or too low, so it's setting this code. What you can do testing this, you can look first. You want to kind of look back and make sure you don't have 746 code. You'd want to check that code also, or pressure. Make sure the mainline pressure is good. Then you're going to also refer to code P0778, which is coming up here next, and P0840. So this code has a lot of different stuff in it, and you're going to want to refer to these other codes to make sure they're good also. So this is kind of last on the list to check. On the scan tool, you can look at the desired primary and secondary pressures and compare. So they have the desired pressure and the actual pressure on the scan tool. See if you see a difference there. Note, not all the scan tools are going to have this information. Factory tool will, of course. Some of the Snap-on does, some don't. The Hotel does a lot of times. So this is going to vary on what scan tool you have. But you should see an actual and a desired pressures, and they should match. Main common issues for this code is leaks in the pulley system, sticky water and flow control valve, sticky valves in the valve body. Alright, P0778, pressure control solenoid B. This is electrical code. We're still dealing with pressure control solenoid B. It controls secondary pressure. The TCM detects an improper voltage drop when it tries to operate the solenoid. When the TCM compares target value with monitored value, detects an irregularity. So scanner testing, we can do just that. We can watch the secondary target pressure and the secondary actual pressure and see if they are the same. So here's what we're talking about. ISO L23 is the scanner PID. Solenoid monitor, this is the actual, and this is what the desired is. Solenoid monitor 3 is the what it's monitoring. So at an idle, you want both of these at 0.67, 0.6 to 0.67. Raise the RPM up to 2000 at idle, and you should see the amperage drop a little bit, and they should also match on both these two PIDs. This is the line pressure B solenoid, second one in here. B is going to be pin number 3. Talk about this in the next slide. Here's design 1. Here's your basic wiring diagram. The solenoid is grounded to the valve body. We have one wire controlling the solenoid. Solenoid regulator oil is going between the two O-rings here and out to the pressure regulator valve. In this case, pressure regulator B. First time solenoid has a little nipple on the back of the solenoid here in the middle of the screen. Second design is the main pictures here. Talking about the first design solenoid testing on this slide here. So TCM, let's see, design 1 pin information, TCM pin number 2 and transmission case connector number 3. So between a ground, inside of the case of the transmission, and either one of those two pins, you should have about 3 to 9 ohms. If you want to test the circuit, you could disconnect both these wires and load the circuit, would be one way. You could also hook up an amp clamp and compare the amperage on the scan tool to an amp clamp and see if they're the same. Normal amps are about 0.8 at an idle and drop to engine load. And this is design 2. Everything's the same thing here. Design 2 is a picture, these 3 solenoids. This back here is flat. This is design 1, it's the only difference. Design 2 pin information, the only difference is TCM is pin number 30. The rest of the information is exactly the same. P0840 transmission fluid pressure switch A. Pressure switch A is actually on the valve body itself, and it's measuring secondary pressure. So the description of this is the secondary pressure sensor detects secondary pressure of the CVT and sends a signal to the CCM. The signal voltage of the transmission fluid pressure sensor A is too high or too low while driving. So this sensor here, they're saying that the voltage is out of range. The minimum voltage is 0.2 volts, and that's at minimum pressure, and 4.5 volts at max pressure. So if you get a reading of, let's say, 5 volts on that circuit, it's going to set this P0840 code. Also, if the wire's cut and you get 0 voltage, it's going to set this code. This is a Hall effects style sensor. It has a 5 volt power at pin 1, ground at pin 3, and the signal wire changes voltage. So these pins are at the switch itself. So here is the switch connector and the switch itself here. So pin 1, 5 volts, 3 is ground, and the center one, 2 is the signal. This is for the design 1 transmission. Here's a typical wiring diagram. To lay out what we have going on here. So here's our sensor pins, 1, 2, and 3. The sensor pin 1 is the same as trans connector pin number 20. Design 1 TCM pin 46. So all this row here is the same wire, same circuit. 2 is your signal wire. This row here, 2, 23, and 37 are all the signal circuits. And then 3, 19, and 42 are all the ground circuits. Alright, so that's the circuits. So when we are testing the voltage of the sensor wire, you can do this on pin number 37. at TCM or pin number 23 at the transmission case connector. In neutral idle, you're going to have about 0.8 volts, and this should be reading the same scan tool. So go to ground and either pin 37 or 23, whichever is easiest, and compare that to your scanner reading. If you wanted to check the ground circuit, we're at pin 42 at the TCM and 19 at the transmission case connector. With the engine running, everything connected, you should have about 0.03 volts on the ground circuit. To check the vehicle sensor power, be 46 at TCM, 20 at the transmission case connector, and we should see 5 volts with the engine run. Back up to reading this information on your scan tool. So pull up pin secondary HYDR sensor and secondary PRS sensor on the scan tool. The condition, we're in neutral and we're idling. It should be about 0.8 volts on the scan tool. Cruising down the road at 25 miles per hour, it should drop to 0.4 volts. This is design 1. Design 2, everything here is the same except the TCM pins right here are going to be different. Testing's all the same. Alright, so a P0841 pressure sensor function code. This is a performance code. It's seeing the pressures are not correct for what is commanded. The factory manual also says this code can be set for circuit issues. So if you have like a P0840 or a P0845, to take care of the circuit codes for sure first, and then this code should disappear. Don't have any circuit codes, you're dealing with most likely a pressure issue. So basically this code is saying it's using engine load, the primary speed sensor, secondary speed sensor, to change the pressure of the primary and secondary pulley to change the ratio. So what the computer is looking at basically is the PID, that is PRI HYDR sensor and secondary hydraulic sensor. So on the scan tool, go ahead and pull those two PIDs up at idle and neutral. Looking at your primary sensor here, you should have about 0.7 to 1.2 volts, and the secondary should be about 0.8 volts. And then get cruising to about 25 miles per hour. Look at your primary. You should be at 1 volt, and you should be at 0.7 volts on the secondary. So what you can do is pull up these PIDs, like I said, and then actually pull up the other PIDs for the actual voltage or the amperage on the scan tool and compare those at the same times. So you can look at your primary hydraulic sensor command and your amperage, or monitoring, I think they call it. Need to do a line pressure test, and pulley pressures can help do this testing on the circuit too, to compare to make sure the pressures are within specs. There we go. Finally changed slides. Alright, so the 841 pressure sensor function pressure testing. So here is some pressure taps on here. First, I would like to make sure that everybody knows you need to use the high pressure gauge and hose. It'll handle roughly 1,000 psi. In my opinion, it'd be a lot better off to buy a transducer. You can get the 0 to 5,000 psi transducer and use your scan tool to measure the pressure and graph out the pressure. A lot safer than using a hose and a gauge. So line pressure at an idle is going to be about 108 psi. Line pressure at stall is going to be 826 psi. And then the other thing we could also do, secondary pressure here, we can go ahead and tap into the secondary pressure port and compare that to the scan tool readings and see if they're reading about the same. P0845 transmission fluid pressure sensor B circuit. So this one we're basically are the primary pressure sensor. This is the same sensor as the secondary sensor. It's in a different location. So the primary pressure sensor is right there next to the connector inside the transmissions. Primary pressure sensor is doing that, just detecting the pressure of the primary circuit and sends the information to the TCM. The primary B measures primary oil pressure. It's a Hall effects type sensor, and it's located under the pan right next to the case connector as said here. So Hall effect sensors, what does it have? It has 3 wires going to it. We have 5-volt power, a signal, and a ground. Here's the common wiring diagram for design 1 and the 3 wires. If you wanted to measure scanner testing, you could pull up PID primary hydraulic sensor on scanner. In neutral at an idle, it should be about 0.7 to 1.2 volts. This is normal reading, and while driving, 1.0 volts. So here's the PID and the chart information here. Now if we want to test with the meter, first thing we'd want to do, this is design 1. So pin 41 at the TCM and pin 25 the transmission case connector, the same wire. This is going to be your signal wire. So it should measure what the scan tool says that it has on there. So 0.7 to 1.2 volts at an idle. Checking the power wire for 5 volts. You can do that at pins 46 or pins 20. 46 at the TCM, 20 at the transmission. While the vehicle is running, you should have 5 volts on those pins. And to check for a grid ground circuit, one end of your meter on ground, the other one either on pins 42 at the TCM or 19 at the transmission case connector, and you should have about 0.003 volts. Here is design 2. Design 2 says while idling in neutral, you should have 0.5 to 0.8 volts. So it's a little bit different than design 1. And the testing is the same except the TCM connectors. So TCM pin number 14 and trans pin number 25 should be your sensor wire. And this is the one that's going to be at 0.5 to 0.8 volts at an idle in neutral. Pins 26 at the TCM and pins 20 at the trans should be your 5 volt. And pins 25 at the TCM and 19 at transmission should be your ground circuit.